Looking at the fourth section of two variable inequalities, and this is the start of our 4.0 content. We're looking at nonlinear two variable inequalities, okay? So when we look at the word nonlinear, hopefully something comes to mind, whether it be it's not a straight line, there's a curve, some type of curve to it, and hopefully the first shape that comes to our mind is maybe the parabola, what we just got done working with in an earlier unit with graphing quadratics, okay? So we're going to be looking at two variable inequalities that are nonlinear, specifically parabolas, okay? So this is the process that we're going to use to graph these, and how we're going to decide which side or which plane we're to shade, okay? So the first thing we're going to do is we're going to use our graphing calculator to generate a table of values for the boundary line. After that, we're going to plot the points from the table, okay? We're used to graphing quadratics and parabolas from factoring or finding the x and y intercepts or finding the axis of symmetry or the vertex, the key features of a parabola. Now we're just going to use our graphing calculator to make a table for us, and then we can just plot those points from that table. Okay, once we have those points plotted, we can sketch the graph, and then we'll test the point just like we have been doing all the other previous sections of this unit. Okay, so the first one we have is y is greater than x squared minus 8x plus 15. Okay, the first thing we want to do is we want to generate that table. Now, the way we generate the table is this, okay? So this process here, these are actually exact cutouts of the buttons that you will push in order on your calculator. Okay, you want to hit that y equals button, this button that will actually give you the variable x. This button will give you your exponent for x squared. And you'll hit minus 8x plus 15, and then you'll hit second graph. And once you hit those buttons in that order, it's going to take some getting used to. I know we're not really used to using those graphing calculators in this way. Once you guys get used to using them this way, it'll be so much better and actually more efficient, okay? So once we do that, you should get a table almost like this, okay? The table might not look identical to this depending on which values you pick and how it changes, but it'll look something like this, okay? Now, once we have those, there are points on here that we can plot. So for example, 2, 3 is the first point we can plot. We can't fit negative 124 or 0, 15 on our graph. So 2, 3 we can put, 3, 0 we can put, okay? 4, negative 1 we can put, 5, 0, and of course 6, 3, okay? Now when I look at this, we can see the shape of the parabola starting here, okay? And that's what we want. But I'm going to ask you, is it going to be a dotted or dashed boundary line, or is it going to be a solid boundary line? Hopefully we all said it's going to be dashed because it's strictly greater than, okay? So we're going to have a dashed parabola here, okay? So now it's as easy as just finding a point and trying to test if it's true or not. So we're going to, of course, pick the point 0, 0. It's easy. We're going to substitute 0 in for every y and x we see, okay? Once we do that, we're going to be left with 0 is greater than 15. Now, of course, this is a false statement, which means we will shade the plane opposite of the test point that we picked. So the opposite plane of the test point we picked would be the plane inside of the parabola. Okay? So it's a similar process to the linear inequalities that we've been doing, but it's just different as far as finding the points and plotting them for the parabola, for the non-linear quadratic. Okay? So for our next example, we have y is greater than or equal to negative 2x squared minus 12x minus 16. Again, let's just put that right into our calculator, okay? And this might take some getting used to as far as putting it in, like I said, but once you guys get the hang of it, it'll be a lot easier than it seems to be, okay? So here's a table giving us some points. So let's plot those points, okay? There's negative 5, negative 6. There's negative 4, 0, negative 3, 2, negative 2, 0, negative 1, 6, and then the other two we can't really fit, okay? Oh, we tried to fit them down at the bottom there. That works, okay? So we can try and fit as many points on here as we can. Now, looking at this, we're going to have a solid boundary line. The solid boundary line comes from the greater than or equal to sign here. Our inequality tells us this is going to be a solid boundary line because it's got the equal to part to it, okay? Once we do that, we're going to test the point 0, 0, plug 0 in for every x and y you see. Of course, that's going to leave us with 0 is greater than or equal to negative 16, which is a true statement. So we will shade the plane that contains our test point, which is 0, 0. So we'll shade the whole outside part of this parabola. That whole outside plane gets shaded. Okay? So the only process that's really new to us here, we know how to graph parabolas, okay? We know how to test a point and decide which part to shade, okay? We know which kind of boundary line to use. The only part that's kind of new to us here is putting our actual equation part into the calculator and generating this table. And once you guys get the hang of it, it shouldn't be too bad. Okay. So looking at number 3, we have y is greater than the absolute value of x minus 3 plus 2. Okay, so remember, absolute values are kind of unique graphs in their own way. And we'll see why. Okay. So again, this is the order of the buttons that you would hit to type in this absolute value part. Okay. There's no just plain old button that you can put the absolute value kind of sticks, is what I call them, the outside parts here in. So you have to hit math, the right arrow, 1, and then that would actually put your absolute value signs in for you. Okay. Either way, this is the table that's generated. So let's plot some of these points. Okay, there's negative 1, 6. There's 1, 4. There is 4, or 3, 2, sorry. And so on and so forth. Okay, so remember, if we remember right, absolute values are graphed and they look like V's. Okay, parabolas kind of look like U's. Absolute values look like V's. Okay, so this is a dash boundary line because it is strictly greater than. Now we need to pick a point to test. Of course, the easiest one to pick if it's not on the line is 0, 0. We're going to plug 0 in everywhere we see. Now when we simplify this, 0 minus 3 is just negative 3. But the absolute value of negative 3, remember the absolute value is the distance from 0. Okay, what is negative 3's distance from 0? Hopefully we all said 3. Okay, 3 plus 2 is 5, so we get 0 is greater than 5. This, of course, is a false statement. Okay, so we would shade the half plane opposite of our test point. So we wouldn't be shading below this absolute value dash line. We'd be shading above it. Okay. So remember, absolute values kind of have that V shape. So if you're trying to graph the absolute value or plotting points and it doesn't look like it's going to be a V shape, then that would not be, you probably somewhere in typing it in your calculator messed up. Okay. So for number 4, we have y is less than or equal to the negative absolute value of x plus 2 plus 1. Again, put that in your calculator. We'll generate this table. Okay. Let's plot these points. Have all these points plotted. We can just see, obviously, it's going to be a solid boundary line because it's less than or equal to. Okay, so there's my solid boundary line. This is facing down now, so it's a little different than the last one. Okay, pick a point to test. 0, 0 is still not on the line, so we can pick that point. Okay, plug 0 in everywhere we see. 0 plus 2 is 2. Okay, the absolute value of 2 is just 2. So we'd have 0 is less than or equal to negative 2 plus 1. Now this negative 2 is coming from distributing this negative sign to the absolute value of 2. The absolute value of 2 is just 2. Then we add the negative onto it. Okay. Negative 2 plus 1 is negative 1. Is 0 less than or equal to negative 1? We would say that is false. 0 is greater than negative 1. Okay. So we would shade the plane opposite of our test point, which would be the bottom part of this absolute value. Okay. So we'd shade that whole bottom part. So that would be it for the first part of the 4.0 content in this unit, guys.